everyone. In today's lesson, we're going to be talking about rational and irrational numbers. So, without much further ado, let's go straight into our lesson. So, starting off, you're probably wondering, what are rational numbers? Rational numbers can be any integer value that can be expressed as a fraction. Rational numbers can also be decimals that end or repeat in a pattern. Now, there is a minor rule going back to the first bulletin point you see here. So 0 is an integer value, of course, but it cannot be the denominator of a fraction. You can express any integer value any way you like as long as it's a fraction, right? But 0 is a little different. 0 has to be the numerator of that fraction and not the denominator. It's still an integer, just has to be treated a little differently than the rest. Now let's look at a few visual examples. So as you see here, I have -9, 0, and 3. What if I try to turn these into fractions? Well, I would have -9 over 1, 0 over 5, and 3 over 4. I can make this into any fraction form with any number I want, as long as it's an integer value, and they can be expressed as fractions. Now, if you take a look at that 0 over 5, you see that 0 is the numerator and not the denominator, and that's a very important rule that we have here when dealing with rational numbers, that 0 has to be the numerator, okay? Now let's look at a few decimals. So I have 0.181818. This is a valid rational number because it repeats in a pattern. Likewise to the 0.40 and 6.7777 you see on the screen. These are both valid. 0.40 ends and it's a decimal, and 6.7 repeats and it's a decimal. I can also have -2.5, and that would be a rational number. It is still valid. It's a decimal that ends. And you, of course, can have negatives, by the way. So now let's take a look at irrational numbers. Irrational numbers can not be expressed as fractions. So you could take any number, but if it cannot be expressed as a fraction, it makes it irrational. Irrational numbers can be decimals that are never ending, and irrationals also can have decimals that have no pattern and never ends. They can also be pi, square roots, Elmo's number, or the golden ratio. Now let's take a look at these visually. So as you see here, I have pi, Elmer's rule, golden ratio, square roots, and a decimal at the top that doesn't have a pattern and never ends. These are all examples of irrational numbers. So when you come across any of these, just know that they are irrational numbers, the complete opposite of rational numbers. So this is all for today's lesson, and I will see you guys in the next one. This is Ari the Math Tutor, signing off. Bye!